Hello, everyone. Thanks, Caroline, for the introduction. So, yeah, my name is Ritik, and I'll be talking about how do we filter bad ads by using LLMs to kind of do some kind of selected ad blocking. So it's basically this. It's in direction towards automated detection and evaluation of problematic allowed advertisements. So yeah, I mean, everyone in this room has kind of worked with or come across advertising in one form or the other. It's an art of persuasion, sort of trying to influence or inspire consumer choices through targeted communication. But advertising has its own perils. So first off is tracking. It kind of tracks user preferences, user activities and stuff online. It can show users problematic and predatory content, which can creep out users. Then we have ad annoyance, where excessive number of ads can irritate users and hamper their browsing experiences. And finally, we have malware or scams in the ads, which can compromise user security. So what's the solution? Ad blocking. Block all these ads and you don't have all this problem. But I don't think I want to talk about ad blocking because I think most of the people in this room know better on it than me. But I want to look into allow listing, as in what not to block. Or if there exists this holy grail in between which separates what ads can be blocked and what ads should not be blocked. So taking a page from PageFair report, I don't know if people can see the numbers, but more and more ad blocking on the web leads to web revenue being distorted. There's different amounts of money being lost in different geographies. And this encourages different players to kind of develop more advanced tracking techniques, a sort of part of the cat and mouse game. Also, there's a lot of increased web breakages. So a lot of studies have come up that show that due to ad blocking, we have a lot of web breakages and also differential treatment of ad block users. Some example of it we'll see later. And finally, there's a lot of attempts at at allow listing. So basically, we have Brave rewards, we have Brave ads, we have DuckDuckGo Bing ads, there's ABP acceptable ads, there's AdGuard search ads, and more. Not uBlock. uBlock is purest. If you don't like ads, just have uBlock. So cool. I'll kind of distribute this talk into three parts. One is sort of the things that we discussed last year, as in okay, these are some proposals that we want to kind of look into this direction. Some of the results we have, and what are the next steps we are working on, and can have some feedback from the guys out here. So just to kind of have a brief overview from last year, there's this acceptable ad standard. It was established in 2017. It kind of tries to respect user experience and then deliver real value to advertisers and publishers. It has certain rules in place where there should be distinction in how the kind of ads are placed on the web page. For example, we see ads being kind of explicitly mentioned where these ads are there. There's regulations on sizes and features where the size of the ads cannot exceed certain part of the viewport, and also the adoption where there's an allow list which kind of sits in between the whole blocking infrastructure, and if its exchange is a part of the allow list, it kind of gets shown to the publisher. We tried to do some review analysis through the web store reviews of AdBlock Plus, and we found that more than 90% of the users were dissatisfied with acceptable ads, and there are multiple reasons for it. Some of the people don't like allow listed ads. There exist other alternatives which have complete blocking. Also, there's at some points there's not much awareness about acceptable ads, as in why are these ads shown to me, or how are these ads kind of getting filtered. But on the other hand, a lot of reports suggest that a lot of the users are neutral to seeing ads. Or even sometimes optimistic about seeing ads where ads that are relevant or non-intrusive. And this kind of brings us to an important juncture where we see some contradiction where people want to see ads, but at the same time, if they're shown ads, they're not kind of happy with them. So we sat back and like kind of thought that what could be one of the reasons behind this discrepancy. And we wanted to dive deeper into the content of these ads. So in order to do that, we first need a definition, which can be used to automate this detection. So we define problematic ads as something which like the audience finds unsuitable. And this kind of expands on to include like auto-playing ads or deceptive practices, dark patterns. But this is still vague at a high level. So we kind of break this down into 6 major kind of subtopics. So first is inappropriate or offensive content, which is like ads with insensitiveness towards races, violence, profanity. We have deceptive claims or like exaggerated benefits. So all those financial claims, overpromising claims. We have political and socially sensitive topics. So like ads around propaganda or like not having appropriate disclosures. We have dark patterns and manipulative design. So clickbaity ads or Gen Z ads kind of fall into this. We have regulatory violations. So we look into like ads across different geographies based on the rules of the land, where like gambling ads or weight reduction regimes or like cannabis ads and stuff. And lastly, we have user experience disruption, where low quality ads or ads with like not visible advertiser information sort of falls into this. So now, given we have this definition in place, what are the questions that we can ask? So first is like, do privacy conscious users face a higher risk of exposure to problematic advertising? And with privacy conscious users, the core focus is users with AdBlock Plus installed, where they're like kind of trying to look for a private experience on the web. Also, is this kind of problematic ad prevalence like kind of focused towards certain geographies or certain age groups, or is like similar across different places? And finally, the bigger question is that, can we use VLMs to kind of automate the detection of these ads? I'm explicitly using VLMs because like we are dealing with image ads. So I want to like not just have text-based models, but also models which can like ingest images and videos, maybe if like everything goes on track. So to kind of design the experiment, we have like 2 phases. One is coming up with a taxonomy, and another part is to collect these ads and kind of annotate these ads. So in order to come up with a taxonomy, we like go through all the academic articles that are present, as well as all the ad policies for different exchanges like Meta, Bing, Google, etc., and then apply some NLP techniques to sort of get the taxonomy. So we essentially focus on 5 different sources. So these are like ad exchanges policies, ad consortia like acceptable ads or coalition for better ads. We have academic studies and industrial studies. We process these sort of white papers and consolidate them into 6 major categories. And last thing, which is kind of the highlight or the novelty of this taxonomy, is that we use certain keywords to define each broader category that we identified in the previous stage. So this is an example for regulations where, for example, prescription drugs or tobacco, or even like non-compliant content, these kind of keywords are used to define this broader category. And we'll see later that how they get used into the prompts to kind of help the VLMs to detect this at scale. For the ad annotation part, we like collect ads from different geographies like US and Germany, and also across different age groups. And then we used certain expert human annotators who are trained on our taxonomy to kind of discriminate between good and bad ads. And finally, we use a vision language model along with some prompt engineering to kind of do the automated detection. So now, okay, we have talked a lot about what's going on with this research methodology. So where are the numbers? Okay, so the first result is we find that on across like the 6 categories, there's a 13.6 increase on average in the problematic ads. And this is also kind of varying across different categories. So if we see the dark patterns or deceptive practices, the acceptable ads are still like perform closely with the usual ads. But for example, for the political ads, we see a huge increase for the acceptable ads case. And also for the inappropriate content, for the underage populations, we again see a steep rise for the acceptable ad scenario. So, I mean, like, if we see across different categories and across different geographies and age group, we find a consistent pattern where the ads within the acceptable ads realm is kind of problematic. Also, there's this interesting graphic here around differential treatment. So we looked into the ad exchanges where these ads are kind of sourced from. And we find that the ratio of problematic ads for each exchange kind of increases. I mean, there is few exchanges for which it decreases as well. But essentially, there's this pattern of increase in the ratio of problematic ads. And this poses a whole new set of questions to us, which we did not explicitly kind of look into. But for example, if we see Criteo, it sees a steep rise in the ratio of problematic ads, but you would assume Criteo to be a kind of fairly good player in the market. And on like deep diving into the stuff, we found that there are few resellers that get changed when Criteo comes through acceptable ads whitelisting compared to when it's coming to the normal users. So Criteo stays the same across the both paradigms, but it's the resellers through which Criteo kind of gets its inventory is what changes. And then that causes this ratio to go up. And this is like similar for other exchanges as well. Finally, the results for the automated detection. So here we work with GPT-4o Mini, which is like one of the smallest closed source APIs that was available early this year. There's 2 sections. So we have no keywords and keywords, and this is where the difference kind of comes in. When we prompt the LLM with the keywords for each category, we find significant agreement with the ground truth that we have developed through human annotators. And this is around the ballpark of 70% accuracy, which is way better than like all the previous results that have been done before on this word. And to go a step further, we wanted to look into, okay, we tried to do something with the prompt, but would increasing the model strength would kind of benefit this detection as well. And we found that the accuracy does not increase as much if we increase the model size, increase the model strength. I believe like it's like around 3 times bigger than GPT-4o Mini, GPT-4o in terms of parameter size. So this kind of brings us to a juncture where we see that if you keep on increasing the model size, the detection capabilities do not increase as much. So this brings us to the like kind of next steps, as in like how can we sort of go ahead, because this accuracy might be wonderful, but it's not industry grade. Like if we want to kind of implement this model at a large scale, we need higher accuracy. So accuracy is one aspect, but we also want to look into diversity, as in like content is one part, but what are the other domains where this automated detection can be extended? So like to deep dive into the accuracy aspect, this is kind of a typical machine learning chart that someone sees when they want to kind of go ahead and increase their accuracy around any classification task. So looking at this, we found that we have explored the like extent of prompt engineering. So one idea is to like have some very curated data set which our model can kind of retrieve results for and then do the classification. But that requires having very updated large data sets, which is pretty impossible to have. So we went to this route where we can take a smaller LLM and kind of fine tune it with some of the like very targeted use cases and then increase the accuracy from there. So there were a few challenges, and this is still an ongoing work, but we'll talk about a few of the decisions that we took to address the challenges. So first was, do we want to use an open source LLM instead of an API? We went through the open source route because number one, it's cost effective. It's easier to kind of turn down the guardrails. All these closed source API has very significant guardrails. And also we can control the size, like what models do we want to use. We went with the smallest models that are available online because the eventual goal is to scale this operation to as many endpoints as possible. So we went with a 2.5 billion parameter model for Qwen 3. I think the smallest model for Llama is around 8 billion, and Phi has a 3 billion model for vision related tasks. The other part is to have a diverse data set. So the smallest Qwen model has around 2.5 billion parameters, which requires around 200 curated ad images to train for each category that we identified. And we had around, like after annotating around 1500 ads, we just had around 60 images per category. So it's still a very small number. And if we want to go to that level, we'll have to have significantly high human work. So we go to a solution which is a very preferred one, which is like using an LLM to train an LLM. And it's called synthetic data generation. So we kind of use 3 different models, which each of them has their own strong points. So for example, realistic vision by Hugging Face, it's pretty good to generate human-related ads. Stability AI is pretty good with product-related ads, where you have like certain products being advertised. And Open Journey, which is a spin-off from Mid Journey, is pretty good with generating flashy or substandard ads, where like you need lesser guardrails over there. And then this whole generated data set, which was synthetically generated data set, was again validated through human annotators to sort of remove the edge cases and ensure that the ads are coherent with our definition of problematic ads. So just with our initial results, we found a 10% bump in the accuracy. So we are around in the ballpark of 82% right now. The eventual goal is to reach 90%. But this is sort of pretty positive in terms of like using a smaller model with highly curated data sets can help us bump up the accuracies. On the diversity front, there was another study from NYU which looked into scammy and predatory ads. So basically, when we turn off ad personalization on YouTube, the prevalence of scammy ads increases by around 2.5 times for pre-roll ads. And the detection for it is hard to scale because number one, this requires some landing page text analysis, as in like when we interact with the ads, where is it leading us to? You need to watch 30 seconds of pre-roll ad content, and you need to capture network level hops as well as look into the companies that are involved, if they are like kind of legit companies or not. So the plan is to also automate this whole pipeline where we do an agentic crawl of the landing page. So basically, we summarize the landing page based on the text and the titles that are present over there. And also the advertisers and resellers that appear in the network hop. So we get one summarization from there. The other summarization is by breaking down video ads into different image frames. And then creating a summary vector of like what all information is present over there. And the final task is to build a reputation signal. We are usually relying with a lot of publicly available data sets of images of advertiser names and stuff to kind of do a comparison between what our agentic crawl gives us and what our reputation signals are, and see that what is the similarity score between these two vectors. At least the initial results were pretty encouraging, where we were able to kind of detect almost all the advertisers that were kind of flagged by this study through this pipeline. Okay, so to kind of summarize this whole talk, I think like there are three main takeaways that I think are kind of important here. Is that modern day allow listing frameworks are faulty. It's pretty hard to kind of see what kind of leaks in through the advertising black box. Under defined environments or under constrained environments, LLMs or VLMs like perform at par or sometimes better than human evaluators, and it's scalable. And agentic frameworks definitely open new domains for improved ad filtering and allow listing. That would be the end of the presentation, and thank you.
Thank you. Great work on this. Yeah, I think there was literally just a new DeepSeek VLM that was released like right before this conference, and I was excited to play with that and make you see if I could do something similar to this. So, really awesome. I was curious if you have released the. I think you said you fine-tuned some model.
Yeah.
Have you released that?
Yeah. So this work is in a submission, but we'll be releasing it, I think, around like 2 or 3 months down the. So we do have released the data set for the previous study.
Okay.
But yeah, we are releasing. We'll definitely release the. And coming on to the point with the DeepSeek, I think one issue that I think over there is, again, DeepSeek models also have a lot of guardrails. That's why I think we did not explore a lot over that domain, but I think it might be nice to play around with.
And the data set of ad images you collected and generated, those are all also.
Yeah, those are available. Yes.
Awesome.
Yes.
Cool. Thank you.
Hi, Ritik. Thank you so much for the talk. I just want to comment a little on, you mentioned that AdGuard search ads and self-promotion lists in the beginning. So for AdGuard, this is not a business model. We were actually asked by different users back then, many years ago. And their argument was that they actually want to see search ads because search ads are at least like moderated and checked, as opposed to just search results, which could be a result of a SEO optimization. But with years, search ads started changing. It was harder and harder to distinguish them from kind of not ads. And they started to take more and more space on the page. So at the moment, we only have this. We don't have it by default on mobile because it makes actually people unhappy. And on desktop, we are not entirely sure now. So in the beginning, like 10 years ago, it made sense to even like not block search ads by default because, it was useful to people. Nowadays, who knows? Not sure about that. But at least, for talking about the content, maybe it's not as bad as the examples that you used.
No, I think the two things. One is, I mean, definitely there's like this rush towards contextual advertising and where search ads kind of come in. And like, as you said, like people like to see search ads as from the feedback.
We had literal requests from people.
Yeah, right. And like I also showed this kind of report by ad filtering page fair and stuff where they also show that people like to see ads as long as they are relevant or non-intrusive. So that kind of divide is
And the other part of the list is so-called self-promotion. This is like a hard question because, it kind of an ad, for instance, on Amazon. That's an ad for some promotion, but people would still like to see it. Or, for instance, on Google, a link that leads to Chrome. So we could remove it, but on the other hand, it's kind of part of Google, so why would we?
Right.
And so to solve this complicated question, we kind of have a special whitelist for like self-promotions.
Yeah.
Then, thanks a lot, Ritik.